Welcome back. We left off on Wednesday just with the very high-level motivation for why we need branches in the first place. We're just very limited the type of programs we can write if we just have this kind of sequential program flow of read in data, do some arithmetic, output data. Generally, for more advanced programs, we want to do some data-dependent decision-making. And when we refer to the term control structures, you could also just use the term branches. That's fine as well. It's just a structure of code that allows us to control the flow of a program's execution. And that most basic control structure in C is the if statement, which conceptually looks something like this, where if, and then parentheses, some value is true, then do something. And I really want you to read it out loud like that when you look at code or you're writing code. Say it out loud. If some condition, then do something. Then is not part of the keyword. There is no then do something. The main keyword construct is just the if statement that we are adding. Unlike essentially every other programming language, C only relatively recently in the last 15 years added keyword support for both having true and false as kind of built-in keywords to the language. They exist, but you'll see all sorts of code bases that don't use them. So instead, still today, most programs in C use a shorthand of true being equal to 1 and false being equal to 0. So one way to kind of reframe that high-level if statement construct above is instead of worrying about if some value is true, instead it's if some value is 1, then do something. I have an asterisk there, a footnote, because it's technically correct. I'm joking here, but I'm required to tell you that technically when in C, 0 is false and anything non-zero is true. And programs do use this fact all the time in C. So if we want to be really, really precise, the correct way to think about our if statement constructs in C is if something inside this parentheses evaluates to non-zero, then do something. Only if what evaluates in here evaluates to 0, then don't do that something. Sure. Any type of variable type, anything that's either 0 or not 0. So what we do then have in C, and what you are generally going to use with your if statements, and I know you've already gotten some exposure to playing around with them, is these relational operators. They are, in fact, quite related to the arithmetic operators, but these are separate kind of operators we can do with our values, our variables in C, to allow us to store the result of some relational condition between two variables here. And they are the basic ones that essentially all programming languages provide. There's the less than operator. So for example, you can have another variable is going to be set as the result of whether value 1 is less than value 2. So you have less than, then you have greater than, less than or equal, greater than or equal, equal, not equal. These are pretty common across programming languages. Other languages do a slightly separate, different looking operator for not equal. And if you're switching between a lot of different programming languages for a project, you may have to double check which one is not equal because it'll be different depending on the language you're using. But by and large, this is something that is supported in all programming languages. Those operators return 1 if the relationship is true, and they return 0 if it's false. That is not contradictory to what I just mentioned about true being non-zero. That is the case of the if statement. The condition will get taken if it's non-zero inside the parentheses. We then have these relational operators that return exactly what we want. They return 1 if the relationship is true, and 0 if it's not true, if it's false. So just as a very quick sanity check for the class here, if val 1 was set to 5 and val 2 would be set to 4 earlier in our program, and I have these expressions. So the first one is result equals val 1 less than val 2. What will be the value of result after that line? That is correct, but we're not adding them together. For this first expression, if val 1 is result equals val 1 less than val 2. 0. So yes, okay, false. You're right, it is false, but in terms of what actually gets stored in that variable, 0. Val1 greater than val2, what will get stored? 1. Less than or equal to? Greater than equal to. There we go. Equals and not equals. There we go. That is what the relational operator is returning. Although I give this as the example of how we use the relational operators, where we say, here's the operator, and we store the result as a separate variable, in this case called result, we usually don't need to do that. We usually don't need, at least in most common usage of programs, to assign the result of the relational operator to a variable. Instead, the much more common usage case for those relational operators is to take the implicit assignment of the result of 1 or 0 and to then directly check that value in the if statement directly. And that's how you should then be starting to read these if statements. If variable 1 is greater than equal to 23, then print out variable 1 is greater than equal to 23. Or later on in your code, if variable 1 is greater than equal to 64, do something else, right? Then do whatever is within that if statement. As good coding practice, you should indent the code that represents the if being true, the if being taken. It's not required, it's a lot easier to read. And it is a requirement that if you're going to have more than one line inside the if block, you need to use those curly braces to denote all of the code, the entirety of that branch that should get taken when that if statement condition, that relational operator is true. I mentioned, not required versus should be done here. This is definitely a point where, in trying to be clever, you're going to be adding additional bugs here. Here's our most basic, same as is on the slide here, with just a couple of variables, int var1, int var2, enter in a variable with an if statement. In this case, now this is showing an else statement here. We'll talk about that in a second. So if I were to enter in 65, we would get var1 is greater than or equal to 23. Technically, as part of the spec, white space is irrelevant in C. So that is valid. It is valid. It's not wrong. When I look at that, it's not a syntax error. It'll get the same exact result, as is having no indentation at all in your code. I think the editors, and most editors, will try to kind of apply good indenting rules for you. And that's why, I don't know if you noticed what just happened. I just pressed enter and it did sort of auto indent what was inside that if statement. And even if you haven't done so, one of the first things I tend to do when you come to my office hours, as you're very welcome to come today, and your code's not working, I tend to take a look at it and just hit that auto format button, and then that also kind of indented some things around. Not necessarily that it's the exact right way I would format, but at least it's something I can visualize more quickly. If what you're going to have within your if statement is going to be more than one line of code, more than one expression or function call that has a semicolon at the end of it, then you are required to have those curly braces around it. Allow me to suggest it's very good practice to always have those curly braces. In this example here on line 9, I don't technically need them because what's inside the if statement, what is the then do this, is just one line. So I do not technically require those curly braces. But what's going to happen in your program, right? You're going to write it today, and one line of statement inside your if statement is sufficient. Oh, I only need to do one thing if variable 1 is greater than or equal to 23. Hey, I don't need to add curly braces. I've saved 2 keystrokes or something like that in my code. What'll happen tomorrow is you'll look at that code and you'll realize, oh, I actually also need to print out, isn't that great? That is probably a bug. Again, if you have no curly braces, you get one line of if statement here. This next line, and actually originally what this code was, what was on this slide, it was if var1 is greater than 64. So let me go back to the one that was on the slide. What's going to happen in this code when we run it for var1 of, let's say, 7? Any predictions? It's going to print int isn't that great. Whereas just in a quick visual inspection of what this code is doing, shouldn't be doing, it doesn't look right, right? It's like, hey, only if var1 is greater than or equal to 23 should it be printing that out. Well, the code formatter would have caught that for you. So I hit that button again, and it kind of shows just via the indenting rules. Again, unlike Python and other languages, those rules are not required. They're just still pretty good practice to follow. Another way to visualize what's really happening here is you have that if statement, and then separate entirely from that if statement, you just have a random printf in there. And so as good practice, even if you think today that if statement is only going to require one line of code, if I really only want to print out isn't that great for that condition being true, just put that within those curly braces there. And then if it's one line of code or 100 lines of code within that if statement being taken, it's still going to work. It's still going to do exactly what you would expect it to do. So now when I type in 7, it should be printing out nothing because nothing gets taken inside there. Couple takeaways from that. One is the basic structure of the if statement. So just through some practice, you'll get pretty comfortable with doing that. Another one is what is allowed versus what is a good idea. And C as a programming environment to be working with sets you up for some of those decisions you have to make. I don't technically have to follow this practice. Maybe trust me for now, or just through your own experience, you'll learn it's probably still good practice to add those brackets even when they're not strictly required. A third takeaway is code formatting can actually discover bugs. Even though, again, white space, there's no rules regarding how I do tabs and how many spaces I put and things of that nature. Still, it's good practice to have nicely formatted code. It can actually allow you to discover things about your program that just as a human reading a screen and you're tired and working late, you may not have caught. So whether you get into good practice of just indenting and commenting and things like that, just tap that button in Replit and it'll provide you some reasonable formatting. Another final takeaway of that is a good quote I like, that you should always code as if the person who ends up maintaining or grading or reading your code will be a violent psychopath who knows where you live. So for that reason, add your curly braces, add your comments, write your code not just for the moment, not just for the absolute second you're working on it right this second, but for the next time someone else is going to look at it. And maybe you'll be the violent psychopath. You'll be the one looking at your own code later on. And write your code for your future self that, hey, I'm going to have to look at this code. I'm going to have to try to pretty quickly remember what it was doing and make some changes and add a feature and do something to it. Let's make the code and let's not shortchange my future self and do things like adding brackets, even if they're not strictly necessary. So now that we have that simple if statement, it creates that block of code that only is executed when that relationship is true. If instead we wanted to have two separate branching paths, there's different ways we can do it. In terms of visualizing what's happening with just the single if statement, we have variable 1. In this program, we had the example there, if it's greater than or equal to 64, then do something. But no matter what, whether we took that true branch or not, once that branch is over, we do continue execution with the rest of the program. I left it as a comment here, so it doesn't really mean much. But if this condition is true, then we do that printing out of variable 2. But no matter what, I say everybody here, this is the rest of the program. No matter what, that if statement gets executed, we either do or don't do what's within that if statement, and then we move on to whatever's afterwards. But it's also very common to have separate code paths be executed for the yes and the no, or the true and the false side of the branch. And there's two ways we can do that. One mechanism we can always use to do that would be to explicitly set up if statements that are logical opposites for each other. So if I wanted to execute something different, and now just worry about this block of text here, this block of code. So let me just minimize that block up there. If variable 1 is greater than 64, I want to do something. If instead if variable 1 is not greater than 64, well, one way we could do that would be to say if variable 1 is less than or equal to 64. And running out of fun things to do here, I don't know. something like that. Do something else. Again, these are all just toy examples for now. That is definitely one. Yeah, sure.
Are you able to do like a range for like, say if you wanted it, if bar1 was between 23 and 64, could you do that in one line?
Yes, and I was going to get there eventually, but the way we're going, probably not even today. There's these Boolean logical operators that let you encode exactly that. So if var1 was, what would be a valid thing here? What's a range? Let's say it's less than 100 or something like that, and greater than 64, and that's how you would read it, like that. We will talk about that and more formally introduce that. That's how you would logically read that. If variable 1 is less than 100 and variable 1 is greater than 64, only then do something there. That's coming in a couple slides here. In this case, though, what I was trying to visualize or illustrate, excuse me, is this is one way you can encode kind of the false side of the branch via just two sequential branches. Variable 1 is greater than 64, do something. Well, when is it not greater than 64? When it's less than or equal to 64, then do something else. Be a little careful with that logic. It's not wrong, you just have to be able to kind of reason through what's happening. A much more kind of conventional way to do that in C would be via the use of the else construct. So we want to then create two branching paths in our program. You can use two opposing if statements, or just use that else construct to specify what should I do when that same relationship is not true, when that relationship is false. And that's how I want you to be reading this code here. If variable 1 is greater than 64, and get into practice of just saying it out loud, or at least to your own internal voice as you're programming. If variable 1 is greater than 64, I'm going to be doing this, line 15 and 16. Otherwise, or else, I'm going to be doing this. And that's just a very common thing we want to be able to do in our program. Do one thing if something is true, do something else if something is false. But either way then, that if and that else side of the branch are then logically kind of connected in the program flow of our program. And so they should be kind of, whether there's an extra space or not doesn't really matter here, but they should be thought of as being part of one if else construct here, because then no matter what, whether we take the if side or we take the else side, and we do take one or the other always, we get down to that line that's whatever is afterwards, where I put the comment everybody here, where continue program execution at that point here. And in terms of writing program, well, this is why it's not that straightforward of a thing to do. You have to be able to have some mental model of how your code is progressing based on the value of your variables as you're taking these various if statements. What is the value of variable 2 at the end of lines 14 through 22? Well, it depends. And that's the whole point, that it depends. It depends on what variable 1 was, whether we divide by 3 or add 5 or do something else to it at that point. Be a little careful with the equality operator in C. I think it's very understandable to kind of conflate the equal operator or the variable assignment operator with the equality operator, you call it equal equals. Sometimes I do even say that out loud, like equals equals, but it really just means equals. One is just the single equal sign that does assignment of a variable. Versus equals equals is the one that's actually checking if two values are equal to each other. It's such a common kind of introduction to C programming mistake that sometimes compilers will actually look for this and give you a very stern warning that, hey, this is going to be a bug. Trust me, it's a bug. In theory, it should be easy to debug when that happens. In practice, you're not just writing toy examples. In practice, you're writing real code, and you may catch it. It may be 2 a.m. You may not catch it. This is not booted up yet, so I'll refresh this and let this boot up here. For this example, so we're reading in a value. It's loading very slowly. Fortunately, we can still see it. Enter in a number, scanf to read in that number, and I would say almost certainly that is a bug. If input's equal to 3, you typed in 3. I run it, and I type in 6. and it prints out you typed in 3. Well, what happened here? It's a bug, so I'm implying that, yeah, sure. That wouldn't be bad if that's what it did do. Ultimately, what had happened is, let me get another reboot here. Something went wrong. We could just end class early and just have an early weekend here. I'll just open it up on the slide, and you'll have to take my word for it, which is fine. If input equals 3, that is the variable assignment operator. We usually think of these things as being separate lines of code with a semicolon at the end. This is valid C. If input is assigned to 3, we're not checking if input is equal to 3, unfortunately, because it is a bug. It is a typo, whatever you want to call it. We've actually assigned input to be a value of 3. What is the value of input? It is 3. What is our value of true? It's not technically 1. It's anything non-zero, right? So we assigned input to 3. We have a successful assignment here. That if statement is always going to evaluate to true, no matter what the actual value of input was before we executed that line of code. We're back up. If you look at squiggly lines here, and I think if we do our job right and you're running code, you should basically have no squiggly lines on the editor side. We have to sometimes make trade-offs between how much time we want to spend getting little tiny syntactical things fixed versus moving on with other things we have to work on. But in general, highlight over the little squiggly lines. It's not that obvious. It's also not an error. It is the editor and the kind of syntax highlighter trying to give you a strong warning that maybe something could be the matter. And what it's saying is using the result of an assignment as a condition without parentheses. The first part of that is what it's trying to say. You're using the result of an assignment as a condition, which generally is not what you want to do in your program, but it's not wrong. There was no compiler error here on the right-hand side. It's not saying, ooh, you made a mistake. It's not technically wrong. It is a bug in terms of the logic we want. We want equals here, and you wait a little bit, and then there it goes. The thing goes away. Now we type in 6. And it should only print in you typed in 3 when I actually enter in 3 for that value. So it actually does work at that point. Questions about that? It is a pretty common mistake. You'll make it once this semester, even if you've programmed a lot of times before. It's sort of a muscle memory thing. You're using both operators quite a bit in your programs, and it'll just be a mistake, that gets made. But you'll remember back to this moment, and you'll be able to fix it hopefully pretty quickly. Again, another takeaway would be it's not always critical when you get that little suggestion, that little underlined squiggly lines here. Just like when you're using Microsoft Word and you get the little grammar check, it's not always necessary that you fix that either. But it's not a bad idea to take a look at it. And certainly if your code's not working and it's syntactically fine, it's compiling, may not be a bad idea to look at those first and say, well, the code editor seems unhappy about something I wrote. My grammar is wrong. That's the equivalent thing that's happening here. Maybe I should take a look at that first, and then maybe the bug's gone away before I have to worry about adding more debugging statements throughout. I'd like to do one more problem-solving exercise today. Let's try it together using the same process. I just want us to keep going through that process and just maybe to see what we're now capable of doing with just adding simple if statements. So in this problem-solving exercise, we're wanting to sort some values here. A very common task in computing systems. The software you execute and the programs you use are constantly sorting things. Maybe you don't really think about things being sorted, but anytime you look at your email and you sort by sender or by date, you're constantly getting sorted values back out. And so while we will implement a relatively straightforward sorting approach here, it's something we're actually going to look at later in the semester because there's many different ways of doing sorting. Some ways are extremely basic and very slow. Others are somewhat more complicated and complex to understand, but can be significantly faster. For now, we focus on just something very basic, just so that we can get it to work here with our if statement. So in this case, we have our problem specification again given to us, which is we want to sort 5 integer values. So that 5 values will be provided, and they'll be provided in any kind of arbitrary order. And our output should be a printout of those 5 values sorted in ascending order, so from smallest to largest. The hint here is kind of a necessary one. This is a very common code pattern in all programming languages, not just in C. If we use a temporary, like a third variable, and in this instance, I'm okay with you calling it temp. It's truly a temporary variable. Otherwise, that's not a very good variable name. But in this instance, it's truly a temporary variable. You can relatively easily swap 2 other variable values. There's other ways to do this. This is a common approach. If I had a variable 1 called 7, a variable 2 called 5, and I wanted the end result to be variable 1 is 5 and variable 2 is 7, one way we would do so is just by having a third variable to store an intermediate temporary result. Take the current value of variable 1, overwrite the current value of variable 1 with what variable 2 was, and then overwrite variable 2 with what temp was, which was the original variable 1. That gets you from 7, 5 to 5, 7. We can use that to sort our values. There's many sorting algorithms that take swapping into account, and just via repeated pairwise swapping allow you to sort a subset and then ultimately an entire set of values here. So here's my notes again. Our goal is to sort a series of values in ascending order. Sorting implies some sort of order. That's fine. If it's descending order, we would see that that'd be a very quick little change here. With our problem specification, we always want to know what our input is, right? 5 variables, 5 integer variables. And here, if we want to say, what does that mean in terms of code? That would be like int v1, v2, v3, v4, v5. Also not well named, but there's just 5 variables that have no other context. That's okay as well. In terms of our output, also 5 integer. Technically, it said just print out the results. So technically, we don't need to have 5 output variables, but I would say 5 integer variables now in ascending order. So something like v1 less than v2. That's having a little bit of trouble with that. Okay, in ascending order. So, and I guess technically then, since we're talking about the relational operators, it's not less than, it'd be less than or equal to would be fine for that ascending order here. Problem analysis, probably can use if statements. That's part of our problem analysis. Part of the analysis was given, can use a temporary third variable to swap the value of 2 other variables. And that was the example, int v1, v2, and temp. And that would be by storing temp as one value, overriding that value, and then storing that value back out. In terms of algorithm, many, and I'll even put too many such sorting algorithms. One approach, and this isn't the only approach we could do. Check if 2 values are in the wrong order, and if they are, swap them. I would add to that, continue to check values until sorted. Probably to know for certain that that's going to work, we could walk through an example. So I would add that as another header here, example execution. So now we don't worry about variable names. We haven't written any code yet, right? Let's say it's just 7, 3, 5, 1. I don't know why they're all odd. It doesn't matter. If that was our example input, our example output would be 1, 3, 5, 7. What we could then do, I'm not going to be able to make a nice little table here. I could try step, and what is the value of my variables as I do this? I'm not a markdown master here. Step 1, there's a way to do this. Okay, step 1 would be, we'll just manually set this table here, would be 7. I'll format this better afterwards. Doesn't look super good yet. Those are the values that we have here. We can then just start by swapping. Look at V1 versus V2. We need to have some if statement here. So check if two values are in the wrong relative order, and if they are, swap them. Check if two values are in the wrong relative order. Well, if we want always V1 to be less than V2, then we'd be checking something like, what if V1 is not less than V2? What if V1 is greater than or equal to? What if V1 is greater than V2? Something like that, right? If V1 is greater than V2, swap V1, V2. That's not a function we're writing, but using that same code pattern, we should be able to accomplish that. So to start with, check if V1 is greater than V2. This looks a little sloppy, but it'll work. It'll work for our purposes. V1, V2. It was greater than V2. We can do a swap. What can we do next? Any thoughts? That was step 1 began. Yep, sure. Yeah, that's so the decision we make right now really kind of influences what we'd want to call that sort. And there was 2 different ones that I kind of had in mind. One of which each time around tries to figure out what the smallest value is, then the next smallest value, and that's when the next smallest value. That's called selection sort. The other one we can do, you can look it up later, it's called bubble sort. They're very similar. In fact, it should be roughly the same amount of lines of code. It would be, we check V1, check V1, V2. Let's put those in parentheses. Check V2, V3. Check V3, V4, etc. So we checked V1 versus V2. We would now be checking V2 versus V3. It'd be a very similar block of code. We could probably just copy paste it. We would want to swap those. And we would have to do that a certain number of times, then check V3, V4, V4, V5. Doing one pass through wouldn't actually guarantee that we have sorted all of the values. It turns out many of these algorithms, and we will learn about this as the semester goes on, are in terms of the execution. In this case, the term you'll see used in some contexts is order n squared. Don't worry about that yet, or quadratic execution. In this case, that means if we had 5 elements, we need to do roughly 25 things, 25 potential swaps to sort that array. Well, that doesn't seem too bad, n squared, or 5 times 5. Well, we usually want to sort things for when n is a reasonably large number. When n is 5, who cares how we do the sorting? When n is 5 million, then there's a huge difference between doing something maybe 5 million times versus 5 million times 5 million times. And then the performance of your code really does take a significant hit. That'll be later in the semester. Don't worry about it for now. Let's try to implement it. Okay, so we got our 5 integer values in any order. We need to actually get them going here. So the naming convention wasn't wonderful, but here we are. And we also know we're going to need a temp variable. Again, we want it on 1 line, we want it on 2 lines. It doesn't really matter. So we have V1 through V5. Those are our 5 values. I think something you may see pretty quickly here is, well, this code's going to kind of look ugly when we want to go from 5 values to 6 values. We have to change a lot of things here. For now, it's fine. Later, we'll learn, okay, if you want an arbitrary number of values, maybe declaring a separate named integer for each of those values is not the best way to go. But for now, it's perfectly fine. Wonderful. We got to actually read in the values. So a little printf, scanf, maybe a little printf afterwards to verify we got the values. Please enter 5 integer values, let's say separated by commas. We talked about how when we have our scanf, it's going to scan for exactly what we're requesting. And so what's within that format string here really matters quite a bit. So whether I want it separated by commas or not, I have to make that decision. I should tell the user who's using my program, hey, here's exactly how I want you to input your data. How would I have 5 integer values separated by commas? And it's okay if you don't have this right away quite yet. %d gives us our decimal input. And if I want separated by commas, I actually would need to put commas in there. This will look to match 5 integers with commas, and then it'll consume any of the white space we have there. And then in terms of, we actually need to overwrite the variables we're interested in. That's the address of V1, address of V2, address of V3, address of V4, address of V5 at the very end there. No squiggly lines, it seems reasonably happy. I would then add, we haven't done any sorting yet, our little sanity check. And something like, before sorting, vals are, and let's make it look nice, %d, 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 %d. We're just confirming that we actually got our 5 values. For me, I'm working on a sorting program. Even today, what were the values? 7, 3, 1, 5, 9. We got our 5 values. Right? Just to confirm that we were able to do a prompt, read in 5 values, get the same 5 values back out. There's an argument to be made that I'm working on this code, I'm testing it. Do I really want to have to type in 5 values every single time I'm testing my program? And I kind of get that. And there's workarounds, there's trade-offs of that. If you go to in Replit, you can absolutely set up a test for a program where the test for the program will allow you to, if it was working reasonably well today, will allow you to add a set of inputs you'd like the program to be run with. And it'll just run it, and it'll be basically typing in those values for you. Alternately, if you're just getting sick of typing things in, feel free to hard code it, at least to begin with, right? And then basically, you'd be commenting out that line, right? You'd be hard coding the values you wanted to test, and then eventually you would then get rid of the hard-coded constant values and add back in the scanf. The trade-off is really, as I'm working on the code, how frustrated am I going to get typing in 5 values? 5 is not too bad. If it was 50, I would suggest, well, this is not a good strategy, right? You don't want to be just constantly typing in 50 values over and over and over again. You're going to make a mistake. You're going to get, sick of doing it. For 5, assuming we can get this done in 1 or 2 passes of the program, okay, we can afford to type in 5 values a few times here. So for our sorting approach, going back to our brief algorithmic view here, we're going to check V1 versus V2, and that check is effectively this code here. If they're in the wrong order, do that swap. Let's add a comment. I think it's time for our first comment. I would say check, V1, how about just V1 versus V2. Here's our first use of the if statement then. We want to swap if V1 is in the wrong place relative to V2. There's more than one way we could have written this, so there's not like this is the only way this code would have worked. But in terms of reading it out loud, what are we doing here? If V1 is greater than V2, I want to swap V1 and V2. Here, literally as we have written with the temp. Temp equals V1, V1 equals V2, V2 equals temp. For me, this is just me debugging the program. I know I'm going to have to kind of do it all over again. I want to stop there. Well, not like permanently stop, but check. Stop and confirm. Did I at least get V1 and V2 sorted? Yeah, question.
I just don't quite understand how that temp is working with them swapping V1 through that temp variable.
So yes, basically we're saying here's a little place to store the one result so that I can overwrite V1. That's half the swap, and then that's the second half of the swap there. Let's type in the same value, 73159. Afterwards, it should be 37159. And okay, so far so good. The basic concept seems to kind of check out here. Now we're at a point. Yeah, sure.
Should we do V1 greater than or equal to V2?
Well, the interesting thing about equals is it probably doesn't matter. With ascending order, assuming ties could be broken either way, if it's 7 and 7, who cares if we swap or not? I guess another way to look at it is no harm. Doesn't break the code any. But in this case, do we really want to do a swap if they're in fact not in the wrong order already? Now there was a suggestion we do V1 V3, but instead in this version we do V1 V2, V2 V3, V3 V4, and V4 V5 at the very end. At this point, I would say let me copy paste. Always a downside, of typing, the trade-off of typing what I want to do next by hand versus copying, pasting, and kind of refactoring what I want to do. One isn't right, the other approach isn't wrong. When you're going to copy paste a block of your own code, don't walk away. Don't leave the screen until you've changed and fixed what needs to be fixed when you've done that copy paste. I guess it depends. Are you more likely to make like a syntax error in typing or a logical error in updating your copy pasted code? Everyone may be different with regards to that. For me, I think I'm going to be okay. I'm going to even make sure I change the comments. Now I'm going to check V2 versus V3. And I just have to be really consistent. Everywhere I had V1, it's actually V2. Everywhere I had V2, I mean, it's not that. That's hilarious. Temp equals V2. V2 equals V3. V3 equals temp. I almost did make a mistake there. I think that's okay. Let's run it again. I don't trust myself. This should be 3, 7, and then so it should be 3, 1, 7, 5, 9. Okay, so we have successfully swapped those first two swaps of our iteration. We then have to do it again. Check now V3 versus V4. And maybe this is slower than it would have to be. We do it slow, and fixing V3 is quicker than fixing V2 first. Check V3 versus V4. Starting to feel a little bit more confident. Now let's do V4 versus V5. But you see what I'm saying about the copy-paste issue? I do that copy-paste because I know I'm doing the same operation, same basic structure again. But in copy-pasting, I've added bugs, right? I have to then take a look at what I just pasted back into my own program and really look at that code really carefully, because by default, I've added a bunch of bugs, or at least code that wasn't doing what I wanted it to do. And I need to go line by line, character by character maybe, and confirm that I actually update the values that I wanted. Probably worth a test. It's partially sorted. So we did compare V1, V2, V2, V3, V3, V4, and then V4 versus V9. For this algorithm, I mentioned it was n squared, meaning we're doing roughly 25 things. There's all sorts of minor optimizations we can make, and I think one of the philosophies you'll learn in this course is I don't sweat the minor optimizations. I believe to guarantee that it's sorted, I have to do that whole V1 versus V2 all the way through. I have to do that whole thing 5 times. Possibly only 4. We'll do it 5. So I copy pasted that whole block of code. And now it's pretty lengthy. This is not the longest thing of code we've written so far. You're probably seeing some justification for our looping structures that we're going to be learning next, right? I want to do the same exact thing 5 times. Well, there's going to be a structure that allows us to do that in a relatively straightforward manner. But for now, haven't technically covered it yet. We're just going to run it by copy pasting the code 5 times here. And fingers crossed, yes, now we do get our successfully sorted array back out. Each time through, that's guaranteed that one value is in the correct position. The way we wrote this, the first time you run it, it guarantees that the largest is in the correct position. Next time through, it guarantees the second largest is in the correct position, and so forth. 5th time through, we don't technically need, because if 4 out of the 5 are in the right position, then the 5th one's also in the right position. But there you have it. That's our sorting approach, really just using if statements. As was already mentioned, what if we want to check more complex relationships between variables? What if we want to do something only if age is greater than 64 and gender is set to be M here? There's multiple approaches that are perfectly valid in our programs. This goes to the question that you had earlier. You can set up what I would refer to as sort of chained if statements. I want to do something when multiple things are simultaneously true. The other term you'll hear is sort of nested if statements, and it's a valid programming approach to use, which is, first, we check if the first condition is true. That is one if statement. Then inside that if statement, we have another if statement, and we check if something else happens to be true or not. Only inside that do we do whatever that operation needs to be. Otherwise, it kind of just short circuits, right? If it's not true, we go to whatever's past the end of the if statement. Even if that second if statement is not true, we go to whatever's past the end of that if statement. That is a valid approach to writing more complex if statements for more complex relationships we want to check here. There's probably a limiting factor to it that if there was 15 things we wanted to check, your codes, if we're following good indenting principles and the like, is going to become pretty indented and a little bit harder to read. But for 2 variables, that's perfectly valid. The other complementary, I would say equally valid approach is to use a more complex relational operator. This isn't syntactically exactly correct, but logically what we would want to do is to have this structure that allows us to say, if inside our single if statement, if multiple things are simultaneously true. If variable 1 is greater than or equal to 64 and variable 2 is equal to m, then do something. Otherwise, don't. And logically, you'll learn a lot more about digital logic, and I keep mentioning that as a separate course you will eventually take. But logically, that's sufficient knowledge that there's these terms of and, logical and, or logical or, and that allows us to encode those more complex relationships between variables. And you should just read it as such. The operator is not great. This is a syntactical choice in C. In this case, you would read it with ampersand. Ampersand is totally different than a single ampersand. In this case, you could say it out loud as and, but it's really just logical and. A and B is true only if A is true and B is true. I tend to accent it when I say it because it's important to know it's both have to be true. A or B, and that's the logical or, it's 2 pipes, is true only if A is true or B is true. And then the other one that's most commonly used is inversion or not. Not A is true only if A is false. And we sometimes want to know if something is false, and that would be one way to do it. Just take the condition and just invert it here. So you will learn about Boolean logic in CPRE 281. It is the basis of all modern digital electronics. Using a series of logical operations on true-false values, you can build up much more complicated circuitry, including all of the processors that we use today. With our C programming, and we'll leave things here for today, but we will pick up right here on Monday, you can then take the basic relational operators and effectively chain them together into single, more complex if statements to get the exact functionality you need It really depends on what logic your program requires. Always, though, as you're working on these, reason through what your logic needs to do, say it out loud, or at least write it down, and then there's going to be a corresponding C statement using relational operators, and now using these new Boolean operators that will give you exactly what you need for the variables that you have. Let's leave things here for today. Monday, we're going to pick up right here and dive into some examples of that.